You make me happy when skies are gray. 4.6, completing the square. This is another method to solve quadratic equations. So far, we have the factoring method and the graphing method. Now we're going to use completing the square method. We have a whole bunch of methods, but one method at a time. Completing the square method. Before we do that method, we're going to review a little bit about solving square root problems. Here we have a pretty easy equation. 2x squared is equal to 72. First step is to divide both sides by 2. Dividing both sides by 2, you get x squared is equal to 36. And then to get rid of the square, you're going to square root both sides. Whenever you square root both sides, you have to remember this square root cancels out that little square. And then you have to remember, whenever you have square root on both sides, don't forget the plus and minus sign. That just means there's two answers, one positive answer and one negative answer. 6 and negative 6. Here's another example. First step, subtract 7 from both sides. Oh, we got 36 again. And then we're going to go ahead and divide both sides by 3. And then square root both sides. And then I guess you can simplify this square root of 12 a little bit. X equals plus or minus 2 square root of 3. If you forgot how to simplify the square root of 12, I'll do it quickly right here. You use the factor tree. 3 times 4, circle the prime number, break this down, 2 times 2, circle the 2 prime numbers, and then you look for pairs. A pair of 2's. They go together and they make 1. This loner 3 has to stay inside the house by himself. That's how I got 2 square root of 3. All right, so that's just a little review of square rooting things. Let's go ahead and go into the completing the square method. Solving equations, just kidding. Now we're going to solve perfect equations first. Now, why are these perfect? If you look at some of the numbers, well, mostly this one, and that's the first part of your homework, is they're going to give you equations that equal perfect square roots, like 25. All right, so let's go ahead and solve it using square rooting and factoring. Without doing anything, without making it into 0, we're going to go ahead and factor this side. Put it in parentheses. It is x plus 2 times x plus 2. The quantity of x plus 2 times the quantity of x plus 2. Notice it's perfect because both of these are exactly the same. When they're exactly the same, I don't have to write them twice. I can just write them once and then put the square on top. And then from there, I'm going to square root both sides. That square root will cancel out that little 2. And then the square root of 25 is plus or minus 5. And then there's only one step left. But before that, I'm going to split it into 2. One that's a positive 5 and one that's a negative 5. And then you're going to solve both equations. Subtract 2 from both sides. That one, x equals 3. And that one, x equals negative 7. All right, so that was a perfect equation just because all the numbers worked out nicely. Let's do another one just for fun. If you notice, 16 is perfect. And so that's how we kind of know that it might work out nicely. All right, so let's go ahead and factor this side. x minus 7 times x minus 7. All right, notice it's perfect. They're exactly the same. So I write that as squared. Square root both sides. When you square root both sides, this little 2 goes away. And then the 16 becomes a plus or minus 4. Split it into two problems. One that's a positive 4, one that's a negative 4. And solve. X equals 11, x equals 3. All right, so those work out nice and perfectly. All right. When they don't work out nice and perfectly, we have to make them perfect. Why use completing the square? So this is the method that this section is about. To complete the square, you just take the b term, you divide it by 2, and then you square it. Now that's not going to mean anything to you until we start doing an example. But why do we do this? It's to create that perfect problem that we just did. It'll help you solve the quadratic equation. And it will help you find the vertex of your graph later on as well. All right, so let's do some examples. All right, so let's complete some squares. If you remember, whenever we work with quadratic, here is a general form for being a quadratic. Sorry, it's hard to write with the mouse. ax squared plus bx plus c. Okay, that's our general quadratic expression, sometimes equation, but the b is what we're going to focus on the most. The b is that term. It's the term that's next to the x. To complete the square, you just divide by 2 and then square it. Let's do some examples. Here's our 10. Here's our example. The 10 is the b term. Go ahead and divide it by 2, which gives us 5, and then square it, which gives us 25. So that's the number we fill in, is 25. So on the homework, the second part of the homework, when they ask to complete the square, that's the number they want, the 25. Okay, let's see why that is important. If you try to factor this, it factors perfectly. X plus 5, x plus 5. Let's do another one. Take this, negative 14, divided by 2, negative 7, and then square the negative 7, 49. And why do we put the 49 in there? Because when we are asked to factor, it will factor perfectly. How nice. What about this one? A 5. That number is not nice because you can't really divide it by 2. Well, yes, you can divide it by 2, but it doesn't work out perfectly. So we're going to leave it as a fraction, 5 over 2. 5 over 2, square it, 25 over 4. That's how you do it when it's an odd number. All right, and why does that work? Because when you're asked to factor, you'll get a perfect factor. All right, so how does that look in an actual equation? Let's see. Solving equations. So all of what we just did was to solve an equation. All right, you could have, the other two methods I told you was to factor and graph. So that was last section. Sometimes factoring doesn't work. So if you try to factor this, x here, you have to think of, okay, what times what gives you a negative 3 but adds up to a negative 8? And I can tell you now, nothing does. It doesn't factor nicely, so you can't do that method. The graphing method will work if you open up your graphing calculator, but before that, we didn't let you use a graphing calculator. You would have to graph this by hand, and so that's that takes a little bit too much time and it's not very accurate. And now that you have Desmos, it's nice and easy, but what if I said no Desmos? Then the graphing calculator, the graphing method is a lot harder. So now we're going to use the third method, completing the square. Here's how the method works. You're going to go ahead and first move that constant to the other side. Oh, just kidding. That's the next problem. All right, so move the 3 to the other side by adding 3 to both sides. Now you've created for yourself a little blank space. Okay? Now you're going to fill in that blank space. You're going to complete that blank space by using completing the square method. Take the b, the -8, divided by 2, which is -4, and then square it, and that gives us 16. All right. Now, if you remember the things you were taught in Algebra 1, to keep an equation equal, if you're going to add 16 randomly into an equation, you have to balance out the equation by adding 16 on the other side as well. Okay, so that's important. Whatever you do to one side, you have to do to the other side. So I added 16 to both sides. That magic completing the square number. The reason why is because now this will be perfect. There it is. X minus 4, x minus 4. It's perfect. This side, I just combined the 3 with the 16 to get 19. All right, since it's perfect, I only had to write it once with the little square. To solve it now, you just square root both sides. Remember, when you square root both sides, you have to remember the plus or minus. And then the square root of 19 isn't perfect, so we just leave it square root. One last step, add 4 to the other side. And that's our final answer. X equals 4 plus or minus square root of 19. I know that doesn't look like a nice clean answer, but that is the official answer for completing the square method. All right, I already had this example up, so we'll do the same thing. First, we're going to try to create a blank space by moving the 1 to the other side. And then you're going to make this a perfect equation by using completing the square. Take the -14 divided by 2 is -7. Square it, fill in the blank. It's 49. Remember, 49 to one side, 49 to the other side. This is now perfect. Factor it. It's -7, x minus 7. And this side is just 52. We can write it together. At this point, square root both sides. Remember, when you square root both sides, you get plus or minus. And the last thing to do is add 7 to both sides. Now, I also simplified the 52 square rooted to be 2 square root of 13. Remember, to simplify it, you just do the factor tree and find the pairs. All right, so that is completing the square method. It's a little bit complicated, but go ahead and try it on the homework.